Yeah, thank you very much, Rob, and thanks to the organizers on behalf of WBA for inviting me to give this presentation. I see I have 3 minutes and 35 seconds left, so I'll have to be quick.
The door opens,
So what do you do? Just
they're
they're fixing it. So I'm a fast talker, but not that fast. Anyway, I was asked to give you a bit of a synopsis of the long-term activity that WBA has had ongoing now in the Athabasca oil sands region, just a little north of the Leica airshed, since 1997. And I'm going to start by just making a few acknowledgments, if I can, please. Certainly all the retrospective analysis of international monitoring that I've published, there are a number of key messages that come out. Of course, you have to have the right indicators. They have to be robust. They have to be representative. They have to be backed up by dose-response science. But one of the key variables that makes monitoring successful is continuity in funding and support. And so I'd like to start off by sincerely thanking the WBIA members for their very, very long-term commitment dating back to 1997 for sustained regional monitoring both in air and terrestrial systems. I'd also like to thank the members for their vision in 2007 when Dr. Alan Legge, myself, and Dr. Maynard proposed to members that a significant science enhancement of WBIA's work was needed to gain that credibility. Not to gain it, but to significantly enhance it in the scientific realm. And to their credit, WBIA members at the time saw the need, supported it, and the funding took a threefold step change in 1 year. And I particularly at this time like to thank the WBIA industry funders for enabling this science build during the 2008 to 11 period. Much of what you're going to see here was funding given really beyond the support that was required simply to meet regulatory approvals. So thanks to all of them, and thanks to WBIA staff present and past. The air component objectives in JOSM are shown here. Basically, the keywords are long-term. We want to be able to report status and trends in the long term. We want to make sure we're spanning the range of pollutant exposure, pollutant deposition. If action is to be taken, mitigative action, then it's really important to know which sources are contributing to which deposition. If you're going to make smart decisions as a regulator, as a decision maker, on what sources you need to mitigate. So it's important to know what sources are contributing where. Also, unless air pollution is having an effect on aquatic, terrestrial, or human systems, one could argue why bother measuring it. So there's the effects standpoint as well. And so my presentation will cover both. WBA is a multi-stakeholder organization founded in 1997. It's independent and it's not for profit. Up until April 1, 2014, we were fully funded directly by industry. Beginning April 1, 14, 15, of course, we're largely funded by AMERA under contract. The reason for this science build was not simply to go out and do really great science, publish papers. It was strategically designed and supported at the time to do what some others have brought up in discussion today, and that is to do scientifically literate work that can make its way directly into regulation and policy decisions. And so that's what this science build over a 4 or 5 year period was all about. Very practical, very strategically designed to inform. This is our current membership. We have 38 members currently. We're growing. In 2013, we had 5 new Aboriginal groups that joined us, First Nations, Métis, and Aboriginal communities. This shows you the list of scientists, principal investigators who we currently have on staff or we contract to. They range from Canadian universities, the United States Environmental Protection Agency works with us. John Watson, as you heard, is the Desert Research Institute. And we have a range of university and institute and agency scientists who work with us. So I'd like now to move to JOSM Air Objectives 1 to 4. These are the status, the trends, spatial considerations, and so on. I'm going to talk about our air monitoring network first. And so we currently have 18 active monitoring stations. These are fixed stations that you see in the your upper left. We have approval now to install 3 more stations, April 1 to March next year. As well, we'll be enhancing one of the existing stations to convert it to the 4th JOSM Enhanced Deposition Station for air. So we have fixed stations. We have 4 portable stations on the upper right. It doesn't make sense to go to the expense to put fixed stations everywhere around all the sources. It's not cost effective and it's not scientifically needed. So we have fully equipped portable stations that run on satellite, cell modem, whatever, that we can take to industries, to communities, park them there, and they work autonomously, deliver data to our web every hour, and we can move them around, get maximum efficiency. We also have 1 mobile station you see on the bottom right, which responds to emergencies and plant upsets or if there are community concerns. We have a very large field operations center, and in which all of our technicians are housed, and you see on the upper right, we're building one of the stations. So we buy the shell, we equip it with all of the systems and processes ourselves, so it's fully calibrated when it goes out the door. We also have a highly equipped instrument shop, and on the bottom right, we have the 2nd in the province now gas certification facility, where we recertify EPA-certified calibration gases to ensure their accuracy. This is what the fixed station network looks like. As I said, there are 19 stations working now. As you can see, we measure all the criteria air pollutants, sulfur dioxide, the NOxes, ammonia, fine coarse particulate. We have 2 tall MET towers that provide the continuous data used in regional dispersion modeling. And this year, we've just installed the first ever wind profiler for the region, which allows us to get upper air meteorological characteristics up to 3 kilometers. Believe it or not, currently dispersion modeling for that whole region that underpins environmental impacts assessment is based on the upper air data from Stony Plain near Edmonton, and we felt 3 years ago there's a little bit of a topographical and other difference between Edmonton and McMurray. So that was our initiative to get that and put it in. In terms of time integrated measurements, these are measurements that we just take once every 6 days, for instance. We have a full suite of fine coarse particulates. We also do polycyclic aromatic compounds and volatile organic compounds. And we have some 25 sites out in the Boreal Forest where we do passives. And we also have quite a bit of specialized monitoring at the trace level and targeted at odor-causing compounds. As well, since we signed an MOU with Environment Canada in 2010, we provide considerable, probably 3 FTEs of support to various Environment Canada initiatives in the region. It makes much more sense for us to do the on-the-ground work than people flying out from Ottawa or Toronto. Who oversees us? Well, we've had as our foundation in WBA multi-stakeholder technical committees. The AIR committee meets once a month. And this is where we get that transfer of knowledge between the regulator, ESRD, industry, and others, First Nations, that attend these meetings. So we're constantly have this oversight from our members. Our program has been reviewed a number of times, as you see, the last one being in 2012. As well, we do our own independent audit every 3 years. Like LICA, like the other airsheds, the government audits our stations once a year. Our stations are also alarmed automatically so that if, say, an SO2 concentration in Station 7 goes above the ambient air quality objective, automatically there's an alarm message that goes out to the companies and to the province so that they know there's been an exceedance. Because we're working up north, we're working in a very costly environment, Fort McMurray, we've had to develop what we call a hybrid model of employee, contractors, and scientists. So to run this station, remember we're monitoring in an area of 68,000 square kilometers. One of our stations we fly to, some of them it's a 2-hour plus drive. So we've evolved a hybrid model, and we have 4 senior people with over 80 years experience and 10 technicians, and we have 3 people who just develop our data processing systems and data management. With our field operations center, we've evolved quite an efficient turnkey facility so that we can build these stations, get them out. For instance, with the 1 month's planning, we were able to take a station up the ice road in March to Fort Chip, replace the old shelter, and with one day it was online reporting publicly, and that takes an awful lot of planning. There aren't a lot of electricians and other services up in Fort Chip. And so our data recovery is typically averaging 98, 99%, including the meteorological instruments, which typically freeze a lot in the winter. Because of this facility and because of our on-site staff, we've been working with our partners under JOSM, Environment Canada in particular, and you see here 2 of the scientists from Environment Canada Edmonton who have been working on a mercury and particulate matter at one of our stations, and so we've done quite a bit of work with them. We typically look after all the on-the-ground filter changes, all the routine maintenance, shipping filters, and so on. And this really, I think, gets much better bang for the buck for all the funders. And we've actually modified, in just the last few years, about 7 of our monitoring stations to accommodate Environment Canada and JOSM activities. We've developed proprietary data systems. We have Docket, which is the computer-based field technical notes, which contain all of the information, site visits, notes on any adjustments made to analyzer, and that's there permanently so that anyone who wants to access our data in the future, if they see some numbers that look a little odd, they'll be able to go back to this database, and these data will help them interpret why that number may be the way it is. And we also have a very detailed chain of custody, computer-based, so we know the serial number on a canister, when we received it, the pressure, and so on, and then basically where it ends up when it comes back. This is all really, really important that we document all of this. As of several weeks ago, all of our current 18 stations in the portables are now all digital, and they're supplying digital data, so we don't have to do the analog digital conversion. And we've developed a proprietary remote diagnostic system that you see before you, so we can see the lamp temperature on a sulfur dioxide analyzer in Fort Chip, or we can see how a particular pump is doing on an analyzer without having to put a tech in a plane or a car and actually go and go and see. So that's something we've just finished up, and it's a really valuable tool to make us very, very effective and get us ahead of the game in terms of preventive maintenance. We have a lot of data, millions and millions and millions of data points a year just for air. We're of course driven by the Air Monitoring Directive. We use all EPA federal reference methods or Environment Canada protocols in all of our work. Our standard operating protocols for most of what we do were published publicly for the world to see actually in 2013. So our data goes to many purposes. It goes to the governments for the calculation of the AQHI. We have several servers operating, including a very secure server at the Q9 facility in Calgary. We deal with data requests. Our data is available on the web hourly, at least the continuous. And of course, we supply our data at the end of every month to CASA, which is the provincial data warehouse. We also report data, of course, for our stakeholders for particular interests, and our data is used in LARP and other frameworks. So, how do we report and who do we report for? As I said, our continuous data, this is the hourly raw data for all the continuous analyzers, has been available hourly publicly on our web for as long as I can remember. Our continuous data is fully quality assured 4 weeks after the previous month end. We also report the AQHI on our website. It's updated hourly. One word of caution, and that is the AQI is really driven by 3 pollutants, ozone, PM2.5, and NO2. We can, in fact, do have poor air quality from time to time, and the air quality health index does not change, and that's purely because the AQHI is not currently structured to measure, report odor-causing compounds such as reduced sulfurs and VOCs. By the end of March, all of our continuous data, going back 17 years, will be publicly available on our new website, and our integrated data, VOCs, PM2.5, metals, and so on, back to 2009 will be publicly available. Every year we report in our annual report, which is public on the front page of our web. We give a complete synopsis of everything from audits to reports on all of our work to annual summaries of our data, air quality data, done in percentiles in reference to the Alberta Air Quality Standard. So that's kind of the annual summary that we do, and we've done it since 1998. In the annual report, you will find diagrams, graphs such as this. This one has to do with 3 of the VOC aromatics for 2013. So you'll see our data expressed in medium ranges and various percentiles. Same thing for PAHs. You'll see the same sort of displays. So we try to summarize it on a yearly basis for the public. The PAHs and VOCs, of course, are an example of integrated data where we simply take a 24-hour sample once every 6 days. So what you're really getting is an average for 24 hours. There are times when, of course, the concentrations of some of these constituents are higher, particularly toluene, but they come and go. We report using the Environment Canada once in a 6-day protocol. Our data is also used in many other ways. Our compliance data, of course, we report every year the number of exceedances of ambient air quality objectives set by the province of Alberta. Here you see that for 2014, we had 31 exceedances of the 1-hour standard of 10 ppb for H2S TRS, 2 of a 24-hour. And we had 91 exceedances of the PM2.5 24-hour objective, most of those actually attributable to biomass burning and forest fires. What about the Canadian Ambient Air Quality Standards that are set by the Canadian Council of Ministers of the Environment? Our data obviously are integral there, as are LICA's continuous data. And currently there are 2 cakes, one for PM2.5 and one for ozone. And this is in our annual report, which is in press for 2013, and you'll see there that 2011 was a bit of an outlier in terms of the 99th percentile, and that was the year of the 700,000 hectare Richardson fire. But you can see that the averages there, because of that 2011 year, were skewed a bit above what we normally expect, but typically the 98th percentile for PM, running around 20 to 25 micrograms per cubic meter. So this is another way that people can use our data, particularly policymakers and regulators. And that's why we really put more effort into putting our data out in a format where it can be readily taken up by policy folks and regulators. With ozone, of course, forest fires generate ozone as well as PM2.5. So you can see here relative to the fourth highest daily max ozone, which is both the US and Canadian standard. You can see that the fourth highest daily max typically is, at many of our stations, is running around typically 55 to 65 is the typical range we would normally see, so just below the cakes. I've heard for about a year now that the Ministers of the Environment are looking at possibly adopting the US National Ambient Air Quality Standards for SO2 and NO2, and so we just took the 2013 data and had a quick look at it. And you can see that for the 11 jurisdictions shown here, the numbers of stations, say for BC or the oil sands, are the numbers just above the upper range. You can see that 6 of the 11 jurisdictions shown there will have 1 or more stations in exceedance of the US National Ambient Air Quality Standard, which the level is 75 ppb. I understand that the CCME may want to go a little lower than that. The other thing we do is, of course, our data is used by the government to report against LARP triggers. So here you see the number of stations in 2012 and 13 that exceeded LARP triggers 3 and 2. We had no exceedances of the trigger 4 in both pollutants. We had 2 stations exceeding trigger 3 in 2012 for SO2 and 1 exceeding in 2013. Other applications, all of our data are cited in environmental impact assessments done for industry, by industry for regulatory approvals. Our continuous data are always used for model, particularly regional dispersion model validation. That's an ongoing use. I would say on a daily basis that our website is accessed by a wide range of folks in terms of just seeing what the daily concentrations are, what wind directions, humidity, these sorts of things. During air quality events, particularly the big forest fire event in 2011, we were actually supplying the regional medical health officer with proprietary software so that he could get almost instantaneous readings off our PM2.5 instruments. And so the medical folks putting out public health advisories were actually using our data as a basis for predicting whether concentrations were going up or down and what the potential implications were for health. I'm going to finish up now with talking about our terrestrial monitoring program. This really addresses directly Jocelyn Air Component Objectives 5 and 6, which I showed you earlier. Of course, from day one, particularly the last 6 years in WBEA, we've always considered our programs to be integrated, and they're designed that way. So one can't really do this work on the terrestrial systems without having the other ancillary support work we're doing on air. But our terrestrial program since 1998 is really all about status changes and trends in indicators and endpoints. And we're working in the boreal plains ecozone with a bit of the Canadian Shield tucking into the upper right corner. WBEA's been working on terrestrial environment actually for quite some time. I've just excerpted some of the titles of a few of the reports that we have put out, including the consumptive use of traditional resources in Fort McKay, 1997, trace metals and traditional foods, another TEK project back in 2002 and 3, and so on. So we have a reasonable library now of reports that have been done on the impact effects of emissions on the terrestrial environment. In terms of current monitoring, I know the map's probably a little hard to see, but we now operate, after the science build, a regional network of 50 forest health plots. Some 25 are internal to the stands, and so we're looking for longer-term signals, changes in soil there. We purposely, in 2012-13, put in 25 new edge plots. So these are at the edge of the stand where it meets an open wetland. That's where we know the pollutant concentrations are greatest. The idea here, we don't want to just be measuring just before something negative does happen, before we measure a change in tree condition. We'd like to get a very, very early warning signal that something is happening so that we can go and do the required investigations before there is a change in tree condition. We have 23 passive monitors out there. There's no power, so we use passive plates to get monthly concentrations of 5 pollutants. As you'll see in the middle, we now have 6 solar-powered towers that give us continuous full meteorology at 4 levels, 2 above the canopy and 2 within the canopy, as well as soil moisture and soil temperature. So these are solar-powered. It took about 4 years to get the system to where it is, but we now deliver quality-assured, hourly, continuous meteorological data at 6 locations strategically scattered around the deposition zones. This is delivered right throughout the winter, regardless of temperature, sun angle. And we also use some of these towers for some new technologies that we're working on, such as denuders, to get better data on particulate, nitrate, and nitric acid. We also have passive collectors in the upper right, under tree canopies, under jack pine, to get some measure of deposition in areas where there's no power. So we have 23 of those sites. This is a sort of trends that we publish. Here is a 10-year analysis of passive concentrations in the region, extending 130 kilometers, basically east-west, north-south from the main area. We have a few sites where NO2 has been increasing over time, bottom left. Other pollutant concentrations have remained fairly stable as detected passively. And we now know something about the seasonal monthly rhythms in these pollutants, concentrations being much higher for SO2 and NO2 in winter than summer. Pardon me? Yeah. I'm just going to, how much do I have?
2 minutes over.
Oh, God, okay. Okay, these are some of the, I thought I had 30 minutes. Okay. Okay, anyway, these are some of the indicators we measure. We had a peatland monitoring program that ran for 5 years looking at primary productivity. We have a Berry Health Traditional Environmental Knowledge Project, which we work closely. We're led by the elders in Fort McKay, and we're hoping to expand this down south. We've moved since 2008 strategically to integrate air and land systems through some of the work that John has done. So we have, this is my last slide, with the cooperation of industry, we were able to get source samples from the mines, the haul roads, overburden dumps, John's stack filters, and other hauler filters and other sources. So we have a very good chemical fingerprint of the major sources. And we went out the landscape, selected 121 sites, and we looked for the chemical fingerprint of those compounds, 42 trace metals in the lichens receptors, and lo and behold, we were able to explain 94% of the variability in trace elements across the region using actually 2 of EPA's models. This was led by EPA, this work. And so this is very, very important to know because, again, decision makers need to know if there is an issue, which sources are contributing so that the effort and the funds are directed to the right source in terms of amelioration. And we are just completing a similar study this year for polycyclic aromatic hydrocarbons at 120 sites. So with that, I've overstayed my welcome, so I will thank you very much and invite you to visit our poster area at WBA if you would like to know anything further. Thank you.